Function, two things that you need to consider. You need to know how to define functions. You need to know how to invoke them. Definition and invocation. Two things are major things that you need to understand about programming functions, coding functions. Some of the functions that you already know, right? For example, print. That is a function. Do you need to define it? No, you don't need to, because it is already defined, already built. So we call that built-in function. There are many built-in functions available, but it is almost definitely impossible to define almost all the functions that we need. We cannot expect it from the language developer. Python developer cannot do all functions that we want. So many cases that we have to define our own function. Okay, so there are two types of functions: built-in and user-defined functions. In any cases, then we need to have function definition first. Function definitions may be provided. We call that built-in functions. If it is not, then we have to define it. Defining a function is nothing but the coding that we tried to do so far, right? But it is a little more modularized. Not the coding sequentially from top to bottom of your the coding spaces, but you can make a block. So this is one module of a function, and another module of a function, another module of functions. And in your main logic sequence, you can you can invoke one function after another and after another. And in order to invoke a function, if function requires arguments, parameter to pass, then you have to prepare those parameters. And then as you invoke function, you need to include parameters. For example, print functions. Then print, open parenthesis, and then you can put some parameter there, strings. The strings that you want to print. Or you can pass some of the variables, then Python interpreter knows how to evaluate that variable, so get the value bound to that variables and print it. So defining functions. Basically, function is there is an input and output. Okay, function has an input. Input usually comes into the parameter here, right? And then the body of a function is nothing but the implementation of whatever the logic, and finally it can return the output. Not all functions need to return output. Many functions do not need to, right? It depends on your implementation, or whatever the libraries, or sometimes we can call that API, application programming interface, whatever API defined. Like this, input with the value A and B, and it returns output C, then we know the output. Reason that we need to define functions is because we can, it's defined once, used many times. That is the beauty of functions. Okay, function can be defined once. If it is frequently demanded, then it can be invoked many times. By this, blue box can invoke this, gray blue can invoke it, orange box can invoke it, or maybe brown can invoke it. As many times as it is needed, it can be invocations. Invocations is possible. Programming in function, programming of functions can be understood from some simple mathematics. So if we want to make, for example, some value square plus double that number minus 5, they're all, we have a few instances of the equation. They look different, but they can be formalized like this: x squared plus 2 times x minus 5, depending on x. For example, f of 3, then that'll be this first expression. If we say f of 2, then that'll be the second expression here. F of minus 2, then that is this, right? So they're all from the same pattern, same module. So we define once, and we can use it as many times as we want, depending upon the parameter that we send. F of x, then x is a parameter. So depending upon the x, we may express the formula in many different ways. Okay, so that is basically what we would like to do in functions. So let's say if we have this, then this is a function definitions. This is a way that we use these functions. So definition and use. And this function is called called function. This function is called caller function. Caller function invoke the called function. So defining and calling or invoking. We call this function in sequential language. But the same thing can be called methods. If that function is included in an object-oriented paradigm, we call that method. Okay, we'll look at that in the next lecture. Function calls in Python. For example, convert a Fahrenheit temperature to Celsius. Then this is the formula, right? So today's temperature, today is a little chilly compared to the last week. Last week, I thought it's almost summer. I saw many people wearing shorts, although I wear the long because I didn't prepare. But anyway, it's a temperature, the convergence from Fahrenheit to Celsius or vice versa. So this is the formula that we know. This is more mathematical form, right? This mathematical form can be written in codings. And the variables, this input variable x, we call maybe f, and output maybe c. F for Fahrenheit, c for Celsius. So this can be thinking in this way. F minus 32 times 5 over 9. You don't necessarily dot, but you could do. Equals c. Remember that in coding, we have equal sign. This is not equality in mathematics, but this is an assignment, right? So right-hand side needs to be evaluated, and the outcome of the evaluation is assigned to left-hand side. So left-hand side is usually a variable, and this variable c holds the value coming from this evaluation. So define a function which takes, this is a function definition, which is a coding, right? We are defining a function like this. Let's say we didn't look at the language about function yet, but let's say this is a function, then the function takes a parameter, right? See here, in this case f, right? In this case x. and returns actually this computation result, right? Eventually, it'll be C. So that can be written in this way. All right. So let's say user input equals input, enter temperature in F, in Fahrenheit, colon, and next line. Then your cursor will be waiting for you to enter in the next line if you make this. If we don't have this \n, then your cursor is blinking right after this colon. If you have one space after this colon, then that's the position where cursor is blinking and waiting for you to enter in the standard output, which is on your monitor. So if you enter some, then that value into this U input. So U input is a variable holding the value entered by user. So U input. Since U input is a built-in function, this is a built-in function, it takes a user input and returns it in string, right? So U input holds the value, integer-like value, because it says temperature. Temperature usually say some number, right? Unless we say how you feel, then we can say hot. In that input statements, we expect user to enter an integer or floating points. U input itself is a string, and also if U input holds the value that is likely an integer, which means it is not alphabets, but it is number from anywhere, any numbers 0 to 9, any combination of those. If that is 2-digit number, 3-digit number. If it is the case, then we can convert that into integer. We call this type casting, right? This type of this U input in integer that can be cast to an integer, int. So F, that is assigned to F. The variable F now holds a number. So that number is all comments, right? The number comes here and evaluates the right-hand side of that and assign the result to the value C, a variable C. So we have a variable F and variable C and another variable U input, right? F, C, U input. In these print statements, this is a built-in function. This is a user-defined. We didn't make a function yet, right? It looks like this is a function. In this user-defined functions can take not only one parameter, but it could be many parameters. Or sometimes we can have one parameter. So arbitrarily many or none the input parameters possible. There's a print statements. We can make it, right? Today, by the way, usually when you define a function, then you can say some limited, right? I want to the input parameter A, B, and C, then 3 parameters, right? If we can make it flexibly, then that is really flexible programming, right? That is possible in Python as well. There's a little advanced functions toward the end of today's lecture. Yeah, we'll look at that. But anyway, here then, this is a variable, so this needs to be evaluated. Whatever this variable holds, that is the evaluation result. And this is a string itself, so we simply echo this. And C is another variable, we need to evaluate it. And another string, then we simply echo it. So that these print statements can display in this order on your terminal. So let's say this is a function. We didn't make it yet in the right way, but we know there is an input, there is an output. So input is F, output is C. In between, there's some implementation. So this is a function. And let's call this convert to C. This function name convert to C. So this is defining a function, called functions. We can invoke this function in our print statements. So f in f is, this is string, and there is a something not variable, but we know how we can evaluate this. To evaluate this is nothing but is the function convert to C, open parenthesis and close parenthesis, take f. See if there is this function already defined, then supposedly yes, it is already defined. Then according to this definition, evaluation can be made by taking f. So we already have f. So taking that f and computation and return C, whatever return from this function definition, that is the result of the evaluation of these functions. So f in Fahrenheit is, for example, 32 in Fahrenheit is the result of this. There is a 0 in Celsius. So 32 degree in Fahrenheit is 0 in Celsius. We know that, right? Today's, I think, a high temperature, high maybe 55 in Fahrenheit. Then I do not know, but it's about 10 degree in Celsius, right? Yeah. So I already explained that. So functions or method, we can create a function, we can define a function independently, or we can create a function within a class, then with def and function name, and a list of arguments if it is independent standalone function. If it is in a class, then so far here the same. But before we list the arguments, we need to put the self. So self is not something shown to the caller function, but self is only the variables that can be used within these function definitions. So when we call this, self is not to be used. For example, when we call this, even if we say here self, comma, f, then f is the real arguments. Self, that is important parameter, but that self is used only within the function itself. So we use, in order to invoke this, we see the argument from the second position. Like this, from the second positions, that we use this. I know this is not simple to understand right now, but because that is Python. But when you learn some other really, really powerful language, like Swift is the current generation's predecessor of Python is Objective-C. You guys heard of the language called C, right? C language. So Swift is the language that we use to develop iPhone apps, iPhone mobile applications, which I teach in one of our graduate course, 555, right? So there in Swift, when we define these arguments in function definitions or methods, it is a method in Swift because Swift is object-oriented programming language. Then usually we need to declare two names for one variable. So one name that is used within that function definition, the other name that is exposed to outsider, which is for the caller of that functions. That much I can explain to you at this level. So self is more likely that is the variable used within the function definition itself. Other arguments then that are exposed to outside. So caller used these arguments when this function is called. So that is a self. So self, the semantics of self means that is an object identifier of on an instance. Like major. In major is a variable called the major. So it could be cybersecurity, right? But in object orientation, it's not independently speaking major, but it should be within a class major. Then whose major? Is it Anthony's major, Angelica's major, Bora's major, Dylan's major? We can specify that way, right? So call, how do you call this? Then we call, give me a second. Somebody's, 1 second. I'm back. All right. How can a method be invoked or functions? If it is invoke independent function like this, then we simply call it, right? Func and values correspondingly to the list of arguments. In object orientation, if it is a method like a function, then we need to first instantiate the class definitions. We call that object. Instantiate that object first. And then the function can be invoked through that object. So object dot function. So dot notation is critical in object orientation. That comes next week. I'm now introducing to you. Okay? So today, you don't need to worry about this, but only call it, right? Like print or input. Defining a function. So the language is in this way. It starts with the DEF, 3 characters. So we're defining a function. DEF space followed by a function name. This is the name of that function. Followed by open and close parentheses. Within, we may have a list of arguments or none, right? In this case, 1 argument. Points, and then colon. After this colon, then that is the implementation block of a function. So we have indentations. After this colon, same indentations, all the way here, return. And then we have conditional statements. If this arguments, if points is greater than 93, this is well-known statements, right? Conditional statements. If points is greater than 93, colon, followed by action according to this condition satisfactions. If points is greater than 93, whatever given points, if it is greater than 93, which means the conditions, this is a condition or predicate, this condition is satisfied, therefore we take the very next statements right after this colon. Then we have L grade equals A. L grade means letter grade, right? This is a grading of a number to letter grade. If it is over 93, A. Over 90, A minus. So over 90 that, 93, then we have an A. If this condition is not true, which means less than or equal to 93, then comes next, elif, right? Other than this, but greater than 90. So whatever A minus is for the conditions, the points is greater than 90, but less than or equal to 93. Because A minus already passed through these statements, which means not satisfied this condition, but satisfies the next conditions. First condition is not satisfied, but the second condition is satisfied. Therefore, A minus can be for the points which is greater than 90 but less than or equal to 93. So all the rest are like that. If you see this, then the elif, 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 finally else. Okay, if this is not the case, all the above, what does that mean? If points is not greater than 65, then letter grade is F. And finally, this is the end of this if statements, right? The conditional statements ends here. And after that, return L grade. Whatever the L grade, then it is returned. So for 1 point, we will have 1 L grade, right? For 1 point, whatever the points given, then we will know what letter grade is. If your letter grade is 1000, then that is greater than 93. So your letter grade is A. If your points is negative 555, then comparing all of this, then when it comes to here, points is greater than 95. No, it is not. Therefore here, whatever the rest, that's applied to here. So if it is negative 555, then your letter grade is F. So finally, letter grade is returned. Can you say points and L grade together? I don't know what send means here, but I think, oh, here's a typo, stand alone, alone. How can they be received? Oh, if you want to, if you not, rather than this one letter, but if you, is there any possible that we can send in a list or a tuple? That's what it is, right? Yes, we can send multiple values in list or multiple values in tuple. Yeah, they're all possible. So this is the definitions of the function. Then we need to invoke. Before I forget this, I need to fix this. And also I need to save before I forget. Okay. And then we need to invoke it. This is also. Let's assume we have 8 dictionaries, student dictionaries. So Adam 79, Sam 88, Peter, whatever the name, the values. And points, what is the Sam's points? Then we can access stud dic, this is a dictionary. And within square bracket, we need to enter the key. So key, is there a key Sam? Then that is the value, whatever value associated with that key, that will be returned. That is the points, right? Once we have that points, then we can invoke grading points, whatever that. Then this grading is the function name here, grading. This function expects one parameter. So instead of actual value, variable plugged here, that variable needs to be evaluated. So this variable needs to be evaluated. Then that is evaluation of this right hand side. Then we know whatever the value comes here. And that value is passed to that function definition in the previous slide. And then in this case 88. Then when 88 comes here, then first PTS here 88. If 88 is greater than 93, no, comes here. If 88 greater than 90, no, comes here. If 88 greater than 85, yes. So letter grade is B plus. And all the way down to the end of this if statements, and then because it says return, so that B plus is returned. So B plus is returned. If we want to enter that B plus to the Sam's, then back to Sam's dictionaries, and we enter the list, points and grade together. Okay. Then this portion is not in this dictionary. Value to the key Sam is not one single value 88. After this, it'll be a list. So square bracket 88, comma, B plus, close square bracket. That is this whole thing will replace this value portion for Sam. I think we did this somewhere, right? We can do this in using for loop, right? Not only for the case Sam, but I want to do entire in this student list in dictionary, so that we could do student list. We don't need to do this, right? Actually, we can simply do student dict here, and then we do this. We can get the points for each key and get the grade, letter grade, and attach that letter grade to the value points, so that together in a list format, that'll be the value to this key. So we have a hands-on labs, more and more. Yeah, okay. So now you guys have Colab, right? Do you have Colab? Bring it up on your web browser. So are you guys ready? Anthony, are you ready?
Yeah.
Okay, good. So function statements. So I already defined it here. Built-in functions, you can say eval, exec, format, input, len, minimum, open, etc., etc. User defined that we need to do that. Actually, for the functions, we need to do define and invoke. Some of the built-in functions can be found here. So those are the built-ins. Okay. So I want you to use some of those. Invoke at least 3 of the built-in functions. Can you do it together? Then one of the functions, built-in function, is so if you want to invoke it, then you know that, right? So you can do print is a built-in function. Another one, maybe if we say 1, 2, 3, that is a list. If we want to see how many, then you need to call the function len. Len takes repeatable. This is the list, so return 3, right? We have a 3, and this list may have more, then it'll be 4. So another function that we can consider, absolute value, so ABS. So A equals 12, B equals -11, then A times B, if we call that, then 12 times -11, then that's -132. But if we want to do, for example, absolute value of B, then that is 132, because this absolute values. Question? So we need to define and invoke. We need to practice that. Define. So len, me, and you. What is the length of me and you? For example, if you want to this is a string, right? If you say len, how many there? Looks like one string. So you may think, oh, this is only one. But this itself is iterable. if we put this all in list, then it'll return 1 because it's one string within this list. But if it is not in the list, then that string needs to be iterable. So what is iterated? What is it repeated within that string? Then character, right? Therefore, it gives us 6. So ME space YOU. So 6 characters. If we have one more space, then it should be 7. Oh, strange. If we do here one after that, then still only that after this. Oh yeah. Okay. So that is this. Yeah, 7. But if they are in a list is iterable, right? So what is repeated in a list? Depending upon the comma, how many commas there are. This is only one, right? One element there in the list. So how many elements there? That's what it is, right? So without that, only the string itself, then how many elements within this? So in this case, the character, number of characters. Okay. So if we say this, yeah, because the split, I want to split based on space. So we have 2 elements there. Okay, this is simply practice. Define a function to count number of characters in a sentence. Punctuations are not counted. So how can you make it? So define a function. So count characters. You need to define it. Count characters. Sentence is given, right? Let's say sentence is invocation is, we'll do here. In this invocation, we do, for example, count char, and then we can do sentence. I want to enter this in a sentence. Okay, that is the sentence. But we need to define this. So how can you define it? We can do total character. Total characters initially 0. And then how many characters? Then we need to, using this, we need to split it first, right? So list is given sentence, we need to do split based upon white space. And then for loop for each in LST, because this returns a list, right? Then we need to count of this. But we know how we can count this within the len, right? So that total characters can be accumulated. So plus equal and len of each. We know the len of that, right? And then we can do return total characters. So define this. If there is any issue, there's no issue, then we need to, this is function definition, right? This is a function call. So if we call it, there are 54, right? If we have here exclamation mark, then that should be 55. Define a function, the count number of characters in a sentence. Yeah. Question? We can practice this. We already had this, right? Remember that we have this in the slide, right? So the one that we had the slide. So we can have here. So that is, there's no error. If there's an error, then we know, for example, like this, an error, then it gives an error, right? So if there is nothing, then which means no error. So function is defined. And then the way that we see on the slide, I am going to copy and paste it. Okay, and invoke it. So SAM's grade is B plus, only the SAM's, right? So homework number 1, can you make it whole thing? I know you have very similar things in your slide, so I don't think you have a problem, right? These things. Function defined and invoked by another, see the following code, and together to invoke code below and trace the sequence of functions calls the function returns. So I want you to see here, this is the first function definition, and this is the second function definition, this is the third and fourth, and finally we have only one function calls, print f1. Okay, all of these functions, there's no the input parameters. So f1 is called first. When it comes to here f1, within that f1, see here, print f2. So f1 itself invoke f2. So when we call this f1, then first statements in this implementation of function f1 is the print statements. So print \t, which means one tab. There's indentation. And lst function is called. Not lst, first function, one st. First function is called. And after that, print f2 before return. So print f2. Come back here, f2. So f2, the first statement within f2 is another print statements where there is a 2 tab. And it's called, the second function is called. After that, rather than completing this f2, print f3. So at this point, it goes to f3. When it comes to f3, then another function, third function is called with 2 tabs, 3 tabs. Then now first return here. 3 tabs and third function done. After this, f4 needs to be done. So when it comes to f4, then 3 tabs and fourth function called, immediately return. 3 tabs, fourth function done. When this is done, then return. At this point, finally, function f2 is completed by returning this with the 2 tabs and second func done. If f2 is done, then that is the point this is done. This much is done from this caller function, original f1 called. This is finally done. And then one thing more to do is return. Finally, 1 tab and first function done. If we invoke this more nicely, then you can be able to see. First function called by 1 tab, and then f2 is called. Therefore, second function is called. Before second function is complete, second function is complete when third and fourth function is complete. After third and fourth function complete, then finally f2 function is completed. That you can see here in this the output. And finally, first function is done. So one function can invoke other, which can invoke other and further. And when that function is complete, then it can return back to the caller functions. So when f3 is done, f3 is a called function at this point, right? Then you go back to the caller, which is f2, that is now complete of this second print statements here. So next statements within f2 is f4 print statements. So you come back here. That is a little bit visualized here. Very nicely, right? Any question? So we explain that. See some example below. Deposit checks. This is the function definitions. We have a list, and this list is this is a list variable, right? That list is at input parameter when this function is called. So this list itself will be here parameter within this function definitions. Okay. So first, in this implementation here, let's say this is a deposit of checks. So this is a list of checks. So I want to deposit $23.9, $23.90. Another check says $34. Another check, $99. Another one's $12 and $100. So I have 1, 2, 3, 4, 5 checks to deposit. Within this implementation of deposit checks, let's say this is a banking systems. Somebody in the bank, this is crime, right? Banking crime, fraud. So within that, some programmer within the bank try to cheat. Third check, I want to change it to $33.35. So third check here, $99.99. But this guy wants to change it to $33.35 instead of $99.99 and deposit it. So if you click that, then total $203.95. So that much deposited. That is returned. Okay. What if we do this rather than this checklist in a list? What if we do in a tuple like this? So this is not a square bracket, but a parenthesis all the way back here. And when I call this, see here, therefore this guy says, there is a problem. If I send this tuple, then if it's a tuple format, this guy says, no. Tuple object does not support item assignments. Tuple formats cannot be modified within this. So if you want to deposit your check, then you better deposit your check in a tuple. With the tuple, this is not possible. If you want to deposit your check in a list, then it is possible to deposit, right? So how much it is deposited actually? If we remove this modification, then it should be $270. But because of this modification, from 270 to 203, this guy's, there's some fraud, right? To prevent this fraud, if we call it this checklist in a tuple format, then this guy checked. There's a problem. Your function has an error. It's not allowed, right? This type of things is possible. Because you guys is cybersecurity majors, you see which ones works, which ones maybe commit the crime. Do you see the difference between these two? That's only because of this tuple. So now you see one more difference. Why we need the tuple, why we need the list, right? I'm not saying the list is always the answer. So different, okay? I'm sorry, tuple. I'm not saying tuple is always better than list. There's no statements. It's not true. But it depends. If you want to keep the original value, and such original multiple original value needs to be carried over the course of transmission, then tuple, right? List has more better things. Homework 5.1. Where's the other one? Homework 5.1. Problem 5.1. Oh, discussion 5.1. So I want you to discuss that. And problem 5.2. This is very, very interesting problem. I wanted to write a function called the get tax rate based upon this list. Depending upon city, we have different tax rates. In Manhattan, if it is clothing, depending upon items, clothing, electronic, others, we have different the rate. If it is a Westchester, simply if it is electronic, 10%, others 9%. Let's say that is a Westchester case. Manhattan, a little different. Electronic and others, similarly 11% and 10%. But clothings, depending upon the amount. If it is less than 100, then no tax. Over 100 and 9%, right? Let's say this kind of a rule is available. So this rule is not a well-formed rules, right? It's semi-structured. You don't need to worry about this. Refer to text table illustrated in chapter 3. No, this is not really the case. You don't need to worry about this. So we have a cart. So somebody at the store, the cart, shorts purchased from Manhattan. Short is in clothing categories in tax purpose. TV sets, that is electronic, but purchased in White Plains, which is Westchester, and so on and so forth. No, we need to say this is, rather than White Plains, we need to say Westchester, right? Westchester. A little bit of a typo. I wanted to change this. So it should be Westchester. If, yeah, literally Westchester, White Plains is in Westchester, but if your program needs to understand that, then you need to put more functions saying that White Plains is within in Westchester County. So we don't want to that, right? Don't make it complicated. Make it simple. So if it's Westchester, then here Westchester. Only two cities, Westchester or Manhattan. So this is Westchester. So another Manhattan. Same thing here. Clothing is clothing, and if it's not clothing or electronic, other than clothing or electronic, all others here. Bread is others. Here, White Plains, rather than White Plains, Westchester. So you have cart. You could have multiple other types of carts. I said ignore this, right? So I would just say, yeah. This is the correct ones. Item in the cart needs to be computed by their tax, and total charge is posted. The tax is computed based upon the table here above. Not in chapter 3, but as above. So we need to define this. This is not complete yet, right? So you should be defining a function like this, defining a functions, get tax rate, and then check out, and you have to complete this, your code, here and there, and then finally it should return this. short 33.99 and tax. So short, that there's no tax. Short is no tax because it is purchased in Manhattan, right? TV 999, tax is 99.90. So this is amount that you have to pay. Then we have notes here. Tax is 99. This portion is 99. Muffin 9.05, $9.50. Tax is 95 cents. So total amount is 1045. Out of 1045, tax is 95. So on and so forth. So finally, you say, please pay the following. So $1,460. So this is the invoice. So I wanted to generate the invoice having this. Any question about this? There's a little. So what you need to submit for this, you need to complete this. This itself needs to be. Remember that it's a copy and paste on your plain text file. For the portion of this is problem 5.2. So you need to say here, let's say, then copy and paste it so that I can run it, right? And I can see which one is problem 5.2. Okay, another here, star arguments. Star. Remember that print statements, for example, then you can print statements as an arguments, right? But how many arguments? There's arbitrarily many arguments or none, even zero possible, right? Is it possible to code that way in Python? Yes, it is, right? So to do that, so one star is needed. So I call that star arguments. One star. Okay, if you have a star as a prefix followed by variable, then that means you will receive arbitrary number of arguments. So we can do how many in this list, and then we can count sum, average, maximum, and minimum. That is possible. So it can be defined, and and also invoke. It returns 1, 2, 3, 4, 5 values. Then when you receive that values, the Python, if you have multiple values to return, then automatically it returns in tuple formats. So that is this. Print these functions. Then that prints whatever returned from this. So that is listed here. And if we say print how many total from, yeah, we can receive this. This is the same as this, right? Receive this individually. We can receive this as a whole, then it returns in a tuple. You can spell out each of this. Remember that here, this is an assignment, right? Output of this evaluation is assigned to left-hand side. But if you see this left-hand side, not only one variable, but multiple those variables. If you have list of all the variables, then that should be the same number of this returning values. If you have 5, then you need to list 5 of those. So you can get each individual value as a separate variable, or you can get as a whole in one variable, but in this case, then that is a tuple. write a code to receive an arbitrary number of integers from user and return the total ones. So as an example, I have for example, if I give a demo, then enter the integer, so 45, oops, it's already shown the code. But anyway, so if I do multiple of those, I'm going to do this. And finally quit. And multi-cap is not okay. Oh, it's not possible. Okay, so actually user can enter multiple times, right? Until it says Q. Then receive all of those. So let's call it U data. And that U data, which data? Then you can invoke that. Using that U data, you need to invoke this multi-calc app AP at the end, like this. Then it should return, yeah, exact same thing above here. We give in a list value, right, or a tuple value. But in this case, I want you to do that in user interactions, okay? Double star, on the other hand, if we have double star, then then it assumes it is nothing but a dictionary. So keywording, this is the function definitions, and we have a star dic. This is a parameter. So double star in a prefix of that variables. Then we can handle this dic using a pair, key and value pairs. So by defining this, if you call this, then this guy's print value and key values, right? This is a key is A and value is number 1. So in this case, we first print key and then value. So key, if you see here, then we don't see this is a really dictionary format, right? This is any variables. It's not really this, you can say number. Okay, I can do here num. I can do here num. Run that. And still, if we see here, you don't see this is a dictionary, right? But knowing that double star will consider num as a dictionary, then given dictionary num for each key, so I is nothing but the key, then we print key followed by the dictionary given key, then we can get the value, right? So it has a key and value pairs. So key first and the value, key and value, key and value, the way that we called here, right? A is a key and 1 is a value, B is a key, 2 is a value, C is a key, and 3 is a value. That is what we have. Or in this case, we first define a dictionary and we send the dictionary with the double star. Or we can do, as we call, This guy didn't say how many arguments that we receive, but simply say star star num. When we call this function keywording, I put 3. I put more. For example, mercy equals cyber. Then cyber, I believe this is a value, then we need to do this way. Then we need to have A is the key, 1 is a value, key and value, mercy is the key, and value is a cyber, right, in this way. If we have here cyber as like this, then it'll give me an error. Why? Because here the first one is the key equals, second one is the value. If it is key, then key we receive as a key, but value needs to be something evaluated, number 1, number 2, number 3. Therefore, in this case, that is, we say string as a value. Then it should work. So this is end of this notebook. Any questions? Today's lecture? One student's already left. Okay. If not, then yeah, homework assignments there, and I'll give you a week to complete, and the rest of next week you'll be free to enjoy the rest of the week, because next week is spring break. You don't have to worry about it, right? And I'll see you guys in 2 weeks, right? So first Tuesday in April. Have a good summer, all. Okay.
Thanks, Professor.
Okay. Goodbye.